Hey everyone, welcome to my channel. In this video, let's solve a couple of problems together, meeting intervals and meeting intervals too. So first we'll understand the problem statement, then we'll see how we can solve the problem. Later we'll look at the runtime complexities, and finally we'll look at the code implementation. So let's dive into the problem now. Okay, so here we are given a list of meeting intervals. Each meeting interval is a tuple of start time and end time. So the question is, do any of these meetings overlap? Very simple. So if they do overlap, then how many meeting rooms are required to run all the meetings? So that's the second question. So how do we solve this problem? Okay, easiest way to check if any of the meetings overlap is to check the start time of one meeting if it is less than the end time of another meeting. So here I've marked the first three meetings. So this is the start time of the first meeting and end time of the next meeting. And this is the start time of this second meeting and the end time of this second meeting. So here we can see that the start time of second meeting is less than the end time of the first meeting. Similarly, the start time of the third meeting is less than the end time of the first meeting. So here two of the meetings overlap. So it's fairly simple. If we sort the meetings based on the start time, then we can check if any of the meetings overlap. So what is the time complexity of this solution? Sorting based on the start time takes nlogn time. So this is the time complexity. Okay, here we don't use any additional space, so the space complexity is big of 1. Now let's see how we can solve how many number of meeting rooms are required to accommodate all the meetings. Okay, in order to calculate the total number of meeting rooms required, so let's sort the given list of meetings based on the start time. So here I've marked that sorted list for this example. Now we need at least one conference room to conduct a meeting. So let's initially have at least one conference room. Now let's iterate through this list. So the first meeting anyway requires a conference room, so let's add this meeting to the conference room. Now let's move to the next meeting. So the start time of this meeting, 10, is less than the end time of the first meeting. That means we cannot accommodate the second meeting in this same conference room. So we need a new conference room for this. So let's create a new one and accommodate the second meeting. Now let's move to the next meeting. So the start time of this meeting, 20. So let's check if any of these conference rooms are available. So how do we do that? So if any of these meetings finish first, that is before this the start time of this meeting, then that conference room would be available. In this case, the start time of this meeting is 20 and the end time, the first meeting that ends is 30, and this is still greater than the start time of this meeting. So we need another conference room to allocate to accommodate this meeting. So let's create a new conference room. Okay, now let's move to the new meeting. So 30, 70. So from this list, from these conference rooms, does any of these meetings finish before the start of this meeting? So this meeting here, 10, 30, so this meeting ends right before the start of this meeting. So this room would be available. So let's allocate this room to this meeting. Okay, now let's move to the next meeting. So the start time of this meeting, 50, is, so does any of these meetings end before the start of this meeting? So this meeting here ends right before the start of this meeting. So we can use the same conference room for the fifth meeting. So the total number of conference rooms required for this example is 3. Okay, so what did we do here? At every step we were checking if a conference room was available. So how do we know if a conference room is available? So from the list of allocated conference rooms, we were checking the meeting with the least end time and comparing that with the start time of the new meeting. If the start time of the new meeting is greater than the meeting that ended first, then that room would be available and we can reuse that room for the new meeting. Now how do we know which meeting ended first among the list of allocated rooms? So we want to find out the meeting that ended first, that is the meeting with the least end time. So in terms of data structures, So what is the data structure that gives us the least or the minimum all the time? So it is a priority queue or a minHeap. So let's visualize this algorithm again with minHeap and see how this works. Okay, let's take the same example again. So here we have a list of meetings that are sorted based on the start time. So let's create a minHeap or a priority queue, PQ, that will keep track of the meetings based on the end time. So let's add the first meeting to this priority queue PQ. 0, 60. Now let's move to the next meeting. So the start time of this meeting 10 is less than the end time of the first meeting. That means there is a conflict, so we need a new conference room to accommodate this meeting. So let's add this meeting to the priority queue. So we'll add it to this left node in the priority queue. Now since the priority queue is sorted based on the end time, 30 is less than 60, so this node will move to the top or the root node and this meeting will come down. So let's swap this. So we have 10, 30 at the top and 0, 60 at the bottom. Now let's move to the new meeting. So the start of this meeting 20 is still less than the end time of the root element of the priority queue. So that means again there is a conflict and we need a new conference room to accommodate this meeting. So let's add this meeting to the priority queue. Now the end time of this meeting is greater than the root element of the priority queue. So the order is fine and the priority queue will stay same. Now let's move to the next meeting. So here the start time of this meeting is the same as the end time of this meeting in the root of the priority queue. That means we can use the same room that we used for 10, 30. So let's remove this meeting from the priority queue and rebalance the priority queue and add this new meeting. So let's remove this. Now the element in the right side of the priority queue data structure will move to the top. So now the end time of this meeting is less than the end time of this meeting. So the priority queue is now balanced. Now let's add this meeting 30, 70 to the priority queue. Okay, so the end time here is less than the end time of this new meeting 30, 70. So the priority queue is balanced now. So let's move to the new meeting. Okay, 50, 80. So the start time of this meeting is the same as the end time of the meeting in the root of the priority queue. So we can use the same room that we are allocated for 20, 50. So let's remove this meeting from the priority queue. Now the priority queue has to be rebalanced. Once again, the last element of the priority queue, that is 30, 70, will move to the root. Now, still the priority queue is not balanced. That is, the end time of this meeting 60 is less than the end time here. So we have to swap these two meetings. So 0, 60 comes to the top and 30, 70 stays here. Now let's add this meeting 50, 80 to the priority queue again. Now we have iterated through all the meetings and the priority queue has 3 elements, 3 nodes. So basically we require 3 conference rooms to accommodate all the meetings. So this is how we can solve this problem. So what is the time complexity for this? The insertion for the priority queue is log n. Each insertion is log n time. And we are iterating through n elements here. So the time complexity here would be n log n. And space complexity is again, the priority queue can contain all of the meetings in the given list. So the space complexity would be big of n. So that's how we can solve this problem. If you learned something new, please do hit the like button and subscribe. Thank you so much. Okay, so let's look at the code implementation in this section. So here we have a list of meeting intervals. Each meeting interval is a tuple of a start time and end time. And this example is the same that we saw in the whiteboarding. Okay, so let's sort these meeting intervals based on the start time. For that, there is a function, a class called compare start time. So that compares the meeting intervals based on the start time. Okay, now how do we know if there is a meeting clash? So there is a function called meetings clash. So this basically iterates through the sorted list of intervals and checks if the end time of the previous meeting, if it is greater than the start time of the current meeting, then there is a clash and we return true. So this is fairly straightforward. Now let's check how many number of meeting rooms are required. For that, we are creating a priority queue here, and the priority queue takes in this new compare end time class as the object of this class as the input. So here we are comparing the meetings based on the end time, like we saw in the whiteboarding. So we create this priority queue, and we have this function called number of rooms required. So for that, we pass in the priority queue and the intervals, the sorted intervals based on the start time. So here we iterate through the sorted list of intervals. Now we check if, initially we offer the first meeting interval to the priority queue. Then we iterate from the element, from the second element in the sorted list. So here we check if the start time of the current meeting is less than the end time of the meeting in the root element of the priority queue. If that is the case, then we need, there is a clash and hence we need a new collaboration room. So we offer that meeting to the priority queue. If there is no clash, that means we can remove the top element or the root element of the priority queue and offer this new meeting interval. So at the end of iterating through all the meetings, so we just remove, we just return this, the size of the priority queue. This will return the number of meeting rooms required. So let's run this code here. So here, this is the list of given list of meeting intervals. So we sorted based on the start time. So this is what we obtain. Then we check if any of the meetings clash. So here, the first two meetings itself clash. So this is true. And the total number of meeting rooms required to accommodate all the meetings here is 3. So this is the code implementation. If you have learned something new from this video, please do hit the like button. I'll be leaving the code, GitHub link to the code in the description below. Thank you so much for watching this video. Thank you.